Hey everyone, so this is practice test 2, practice 4 test 2, and this first video we're going to go through the first about 10 problems or so, and then we'll finish them up um, on the next video, first 15 problems. Okay, first one. Given the following graph of a line, identify the following the matching equation. And so this is problem number 1, and you have a graph that looks something like this. And if you could tell exactly what 2 points were on the line, you'd be able to find the equation of the line, but it's a little bit hard to tell. So the easiest way to do this one is to just go through the answers and see which ones are reasonable. So you have something like this: y is equal to mx plus b. They're all of that form. And m is the slope of the line, and b is the y-intercept of the line. So just by knowing that, you can tell which one of these is correct. So number A is not correct because A has a slope of 2/3, which is a positive slope. This is a negative slope. It goes, as you go from left to right, it goes down rather than up. So you can right away get rid of A and B. C looks reasonable because it has a negative slope and it also has a positive y-intercept. So let's keep C in mind. D doesn't work because it has a negative y-intercept. The y-intercept would be down here at a -5, which is not correct. E has a positive slope again, which doesn't work. F, that one goes right through the origin, so that's obviously not the case. G goes right through the origin. And H, y equals 5, that's just a horizontal line. So the only one of these that works is C, and so C must be the correct answer. Okay? Then, questions 2 through 5 use the following information. A line passes through the points. This is 2 through 5. The line passes through the points 3, 4, and 5, -2. And we're basically want to learn everything there is to learn about that line. What's the slope? What's the equation of it? What's the y-intercept? What's the x-intercept? Okay? So this gives me an opportunity to teach all of you what I teach my own classes. And I think this is by far the easiest way just to understand how lines work. If you have yourself a line and you know that that line goes through the point AB, and if you know that the slope is m, then can you find the equation of that line? If you can do everything there is to know about lines, okay? So this is the key. In order to know everything there is to know about a line, you first of all have to know the slope. A line like this is different from a line like this. It has a different slope. If you had 2 lines with the same slope, but one went through this point and one went through that point, then they're different again, right? But as soon as you fix a point that the line goes through and you also know the slope of it, you've got one and only one line that does those 2 things, okay? If you have a point and you know the slope, you've got just exactly one line. And the question is, how do you find the equation of that one line? And the answer is this. It makes total sense. You say, okay, what's the equation of the line? The equation of the line are all the points x, y which lie along this line. That's what the line is. It's all the points x, y which lie along that line. So let's just choose one. We'll just call this the point x, y right there. Okay, there it is. And then I ask myself the question, what property does this point have to solve? Does it have to obey? Does it have to fulfill in order to lie along this line? And you say, well, if it lies along this line, then the slope of this line is what you get by taking the difference in the y coordinates divided by the difference in the x coordinates. So here's 2 points on the line, AB and XY. So the slope between those 2 points is going to be y, this distance right here is y minus b, because that y coordinate is y and this y coordinate is b. From here to here, it goes from A to this x coordinate is x. So from here to here, this difference right there is x minus a. Okay, agreed? So from here to here is y minus b. From here to here is x minus a. And so the slope of the segment between these 2 points is going to be y minus b over x minus a. Agreed? That's the slope, y minus b over x minus a. And we're told that that slope has got to be m. So that's all there is to it. So then you can multiply both sides through by your denominator. And there's the equation of a line which goes through the point, I'll say through the point AB, and the slope is m. Okay? There it is right there. And you don't have to memorize it because you can just get it easily. Okay? Let's do it again just to see if you can stay ahead of me as I do it. Okay? See if you can stay ahead of me. You just have to own this, okay? If you own this, you are all set. Here's your line. Here's some point AB on the line right there. And we're told that the slope is m. So what do? You say, okay, I want the equation of the line. So I choose a point xy right there. And that's going to be on the line as well. Since that's on the line, then I know that the slope from here to here is going to be, this is x and this is a, so this is going to be x minus a. This is height is b, that height is y, so this is going to be y minus b. So the slope there is going to be y minus b all over x minus a is equal to the slope, which is m. And then you just multiply it through and you get that. Okay, so that's the idea. Okay, that's all you need, and you've got everything you need for lines. So what do we have in this case? We've got 2 points, so we've got the point. We have no trouble with that. We just need to find the slope. So to find the slope, what do we have here? We have the point 3, 4, and we have the point 5, -2 down there. And so apparently that's the slope right there. It looks like it's going to be a negative number. Let's find out what it is. So here's the slope. Choose either one and subtract the other one. I'm going to go -2 minus 4. And now I'm going to have to take 5 minus 3. If you take this one minus this one, then you have to also take that one minus that one. It's the change in the y values over the change in the x values. So that's going to be -6 over 2, which is a slope of -3. So there's the slope. That's the answer to problem number 2. The slope is -3. Now we want the equation of the line. How do we find the equation? Well, we just use this right here. I just say y minus, I choose either one of these. Let's go y minus 4 is equal to the slope times x minus 3. And if you do that, there it is. Let's go ahead and simplify it, solve it for y. You're going to get y minus 4 is equal to -3x plus 9, right? -3 times -3 is a plus 9. And now you can add 4 to both sides, and you're going to get y is equal to -3x plus 13. So there's the equation of the line right there, and that looks like it's number B on our list. Okay, if you would have chosen this point, you would have gotten the same thing. Let's go ahead and do it just for practice. If you would have gone y minus a negative 2 is equal to x minus 5, I'm sorry, the slope times x minus 5, so it's going to be negative 3 times x minus 5. See that? I just chose another point. Then it's going to be what? Y plus 2 is equal to negative 3x minus a negative is going to be plus 15. Now you subtract 2 from both sides, you're going to get y is equal to negative 3x plus 13. Same thing as you got before. Okay, so there's that one. Okay, I'll erase all this just to give myself a little more room. Now we want to know the y-intercept. Well, the y-intercept is what you get when x is equal to 0. So if x is equal to 0, you're going to be way up here someplace. And so y of 0 is going to be 0 plus 13. So 0, 13 is your y-intercept. Okay, that's up there. And finally, that was number 4. And finally, you want the x-intercept. What's the x-intercept? We can see where it is right here. It looks like it's 1, 2, 3, 4. It looks, if I'm drawing it right, it looks like it's a little bit bigger than 4. Hard to know whether I've drawn it exactly right or not. So let's figure it out analytically. So what do? Here's my equation. I want to know what's the x value when y is equal to 0, right? This is the unique point where y is equal to 0. So I put a 0 right here in for y is equal to negative 3x plus 13, and now I solve it for x. The easiest way is to bring my add 3x to both sides. And you get that. Divide both sides by 3, and you get 13 thirds, which is 4 1/3, right? So boom, yeah, that was pretty good there, okay? 4 1/3. Okay, that's probably as good of an answer. Okay, good. So there you go. So that was problem number E. So now let's shift over to parabolas, okay? Okay, my computer stops for some reason at different spots, but it stopped at a nice convenient spot there. So that was after number 5, so now we go on to number 6. So number 6, we start parabolas, and we have a parabola that looks like this. It has a vertex at 1, 2, 3, 4, 5, and then it's down 9. So it looks roughly like that. And we need to come up with the equation of it. So as soon as I see that this is the point 5, negative 9, then I know that this equation has got to look something like this, given the choices we have. The x-coordinate of the vertex is at 5. So any parabola, the vertex occurs at the square of this value right in here. So notice that when x is equal to 5, then that's going to be the vertex. That makes this in here 0. So in particular, when this is 0, then I want the y-coordinate to be negative 9. See that? When x is equal to 0, I'm sorry, when x is equal to 5, then this all becomes 0, and I want the y-coordinate to be negative 9. So it's got to look something like that. So that's one possibility for this thing. If I had a negative number in front, then this parabola would open down. But there are no negatives there. And so I don't have to worry about that. And the other option would be if I had a 2 or a 3 out there. That would basically be the same shape. It would just be it would rise at a faster rate. But we only have one to choose from there, and that's number E, right? E is that one right there. Okay. So all these numbers here in front are 1s, so you don't have any others to choose from. So that one looks good. Okay, that's number 6. Number 7 and 8. Given the quadratic function f of x is equal to x squared minus 10x plus 21, what are the x-intercepts of the function? Okay, so in the first practice test that you from material you had earlier in the course, we learned how to factor polynomials, and that's going to be important here because once we factor it, we'll be able to find out what the x-intercepts are. How do you factor that? You again put x's right there. You want two numbers that add to negative 10 and that multiply to 21. And you don't have too many choices here. We're going to give you pretty easy ones to choose from. So negative 3 and negative 7 will work. Those two things add to negative 10 and multiply to 21. So now if you FOIL this out, watch what happens when you FOIL it. You're going to get x squared minus 3x minus 7x and then plus 21. See that? So it's going to be x squared minus 10x plus 21. So that's the way it factors. And now that it factors, 0 is your friend. You want to know, where is that function going to hit the x-axis? Where will it hit the x-axis? Where will that be 0? And whenever you have the product of things being equal to 0, you know that one of them has to be 0. So you have two options here. Either x minus 3 is equal to 0, which means that x is equal to 3, or x minus 7 is equal to 0, which means that x is equal to 7. So those are the two places where this thing crosses the x-axis. And so those are your x-intercepts. And since it's a positive x squared there, it must go down, come back up, something like that. So it must look roughly like that. Okay? What's the coordinates of the vertex? Well, given a parabola like this, the vertex, it's nice and symmetric about the vertex. So since it goes through 3 and 7, the vertex must be right in between those two things. So the vertex must be 5 something. And so 5 is the x-coordinate. What's the y-coordinate? All you have to do is stick a 5 in here. What's f of 5? F of 5 is equal to 5 squared, which is 25, minus 5 times 10, which is minus 50, and then plus 21. So that's equal to 46 minus 50, which is negative 4. So there you are right there. 5, negative 4. So there's your vertex. Okay? Good. Let's try 9 and 10. 9 and 10 kind of asks the same sort of question, but does it from a reverse direction. 9 and 10 says, okay, we've got ourselves a function like this. And we know that the x-intercepts are x equal 3 and negative 5. Are 3 and negative 5. So let's do the previous problem in reverse. Since those are the x-intercepts, I know that f of x is then got to look like this. If it goes through 3, then x minus 3 would be a factor, because that means that 3 would be an x-intercept. That's the place where it crosses the x-axis. 1, 2, 3, right there. Okay? It also crosses the x-axis at negative 5. 1, 2, 3, 4, 5, right there. So that means that I need an x minus a negative 5. That is an x plus 5 right there. So notice that this function right here is going to be 0, both at the points 3 and at the point negative 5. Agreed? That's what we want. So it looks like that, and now you can FOIL this out. Is that what they asked us to do? Oh, actually they don't. They just say, what's the vertex? Oh, what's the vertex? Okay, so if I want to, I can go ahead and multiply this out. I'm going to get x squared minus 3x plus 5x. See that? Minus 3 plus 5 is going to be plus 2x. And then minus 3 times 5 is going to be a negative 15. So there's the equation of the function right there when we multiply it out. Okay, what's the next question it asks? Or what's the first question? What are the coordinates of the vertex? So the vertex, just like the previous one, is going to be halfway in between here. What's halfway in between negative 5 and 3? The difference from here to here is 8. So if I move 4 over, 1, 2, 3, 4, I'm at negative 1. 1, 2, 3, 4. That's halfway in between the two. So that's the x-coordinate of the vertex. What's the y-coordinate of the vertex? Well, let's go ahead and stick negative 1 into the function. If you do, you're going to get what? Negative 1 squared is 1. Negative 1 times 2 is negative 2 minus 15. So that's going to be what? Negative 17 plus 1 is negative 16. Negative 16. So there's the vertex way down there. Negative 16. I'm sorry, negative 1. Negative 1, negative 16. There's the vertex. Then it goes up from there. See that? It goes up this way and goes up this way. What's the next question? What's the y-intercept of the quadratic function? So now we want this value right there. What's the y-intercept? Well, that's easier to get than the previous one. The y-intercept, all you do is you just stick a 0 into this function and you're going to get negative 15. So there you are right there, 0, negative 15. So there's the y-intercept right there. Okay, very good. These are, if you know these problems, you basically know everything you need to know about parabolas. Okay, so let's see what else we've got. Okay, a little bit later, maybe you'll notice I've changed my shirt, played a little pickleball between problems 10 and 11. How about this one? The question is, find what are the x-intercepts? So the first thing you might do is to try to factor it. Okay, try to find two numbers that add to 6 and that multiply to 11. And you'll have trouble doing it, okay? I don't think you'll be able to find anything. So you give up on that and you say, well, what are some other options we have? Well, one option is to complete the square, depending on what section, what teacher you have. Some teachers teach this and some don't. I'll give you 3 different ways to solve this problem. If you complete the square, here's what you do. You take x squared plus 6x. Then you take half of this number, which is 6, and you square it. Well, first of all, half of 6 is 3, and then 3 squared is 9. So you have 9, and I still need to keep this equal to this, so then I tag on the extra 2 right there. And the reason I did that is because now I can take this thing and write it as x plus 3 quantity squared plus 2. Do you agree? Because x plus 3 quantity squared is x plus 3 times x plus 3, and if you FOIL that out, you're going to get x squared plus 3x plus 3x is 6x, and then 3 times 3 is 9. See that? So this, which is the same as that, gives you this. Well, now that you have this, you can graph it if you want to. If you were to graph this, you'd say, oh, that's a parabola whose vertex is at negative 3, because that's what you have to put in here in order to make it 0, negative 3, and then positive 2. So there's the vertex, and since you have a positive number out there, it means that this thing opens up. And so the answer to where are the x-intercepts is, hey, you dolt, there aren't any. Okay, there are no x-intercepts, so it's number H for the correct answer. So that's one way of doing it. Another way of doing it is you might have a teacher that taught you the way to get the vertex of a parabola, and the way to get a vertex of the form ax squared plus bx plus c. The vertex always occurs at negative b over 2a. And so the vertex for this one is going to be at negative 6 over 2 times, in this case, a is equal to 1, right? 2 times 1, which is negative 3. So there's your vertex. We already knew that. And once you have the vertex, then you know that this thing is going to be here at negative 3. Now the question is, what's the y value? And so you just stick it into the function. F of negative 3 is equal to, if I put a negative 3 in here, I'm going to get negative 3 squared is going to be 9. Negative 3 times 6 is negative 18. And then plus 11 gives us 20 minus 18 is equal to 2. So that gave us the same vertex as we had before. It's just that we didn't do the completing the square. But you still know that the vertex is right there, and you still know that it opens up, and so there are no x-intercepts. So that's another way to do it. And finally, a third way, if you remember back from the first part of the course, we learned quadratic equation. The quadratic equation says that if you want to know where this thing will be 0, that the places where it's 0 is at negative b plus or minus the quantity, or the square root of b squared minus 4ac all over 2a. Okay? So if you happen to know that or remembered it, then you could do that on this one. You're going to get negative 6, because b is equal to 6, plus or minus the square root of b squared is going to be 6 squared, which is 36, minus 4 times 1 times 11. 4 times 1 times is 44. All over 2 times 1 is 2. And that gives you negative 6 plus or minus the square root of negative 8 over 2. And as soon as you see a negative inside the square root, you know that that's telling you there are no real numbers. That's a complex number. There are no real numbers which make this thing equal to 0. That is, there are no real numbers along the x-axis, along the real line, which make this thing equal to 0. There are no x-intercepts. So there you go. There's 3 different ways to solve that problem. Okay, so those are all very good problems involving parabolas. Now let's go ahead and apply our knowledge of parabolas to a couple interesting problems. First one is number 12. A farmer has 60 feet of fence to construct 3 sides of a rectangular region where one side is the barn. So let's say that this is the barn right here, and the farmer needs to make a rectangular pasture area there against the barn, and the total amount of fence that he has to work with is 60 feet. So this is a nice applied problem. This is where in mathematics you need to take the power that you have over math and use the word let. Let x equal the width of the rectangle. Okay, so let x be that, and so that's also going to be x. So that's key. That's the key right there to using mathematics to solve real-world problems, which is the main reason you're learning math and that math is so important, is using that word let. Okay, so once you know that that's the width, then the question is how much length do you have there? You have 60 total, and you're using x feet here and x feet there, so apparently you have 60 minus 2x left for this side. Agree? You have 60 total, you've used 2x for those, and so you have 60 minus 2x for that. So there's the area of the rectangle, and we want to know we want that to be a maximum. Okay, we want that to be a maximum. What's the value of x that makes this rectangle as big as possible? So first of all, the area of that rectangle, given that the width is x, the area is just the width times the length here, right? So it's going to be x times this thing, which, if you multiply it out, it's going to be negative 2x squared plus 60x. So there's the area. And now that you know the area, you want to know where will that function be a maximum, okay? Maybe it's easiest to notice that it's going to be 0. It's going to be 0. The area is going to be 0 when x is 0. That makes sense, right? If there's no width at all, if you put the fence right up against the barn, then you don't have any area. You're also going to have 0 area if this is 0. How would this become 0? Because remember, 0 is your friend. The product of two things is 0. That means that either one of them has got to be 0. So when will this thing be 0? That'll be when x is equal to 30. So there's another spot. Why will that make it 0? Think about it. You have 60 feet of fence total. If you take that fence and just go straight out for 30 feet and then straight back for 30 feet, there's another extreme case where you've gone out as far as you could, but you don't have any area there, okay? So there's another spot where it's 0. So those two spots are where it's 0. You notice that it's a parabola, and so since it's a parabola, the vertex is going to be right halfway in between the intercepts there. And so the vertex is going to occur here at 15 feet, right there. And so the way to find out the total, notice that this thing right here is it's a parabola that's pointing down, and 15 feet is midway between these two spots, and so that's going to be where the vertex is. So if you find out what a of 15 is, what are you going to get? I think this is the easier one to work with. You're going to get 15 times 30 minus, or 60 minus 30 is 30. So that's 450 square feet. So that's going to be the best choice of a rectangular region for the pastures. To make this 15 feet, this would be 15 feet, and you've used 30 up there, and so this would be 30 feet. So it'd be 15 by 30. Okay, so it'd be 15 by 30. Would be the answer. The other way to do it, I guess, if you remembered the formula again, you take b, take negative b, so it'd be negative 60 divided by 2a, or divided by a negative 2a. Let me write it over here. Negative b over 2a. So it's going to be negative 60 over 2a. A is negative 2, so it's going to be 2 times negative 2. So that's negative 60 over 4 over negative 4, which is 15. So there's another way to find out the value of the x value of the vertex. So the x value is 15. Stick it in here, and you get the area. Okay. So there you go. That's a nice applied problem. Then the last one we'll do on this set, and then we'll start another video for the others, is 13, 14, 15. So here's what we have. We have the height of a ball that you shoot up into the air from the ground is given by negative 16t squared plus 120t. Okay, if you throw it up with a velocity of 120, then this thing is going to start by going up, and then gravity is acting on it, so of course it's going to eventually come back down and hit the ground. And so that's the general path of it. It's going to go up and come back down. And the first question we have is, when does it hit the ground? So we want to know, when is the height going to be equal to 0? So this is 13. When hit ground. And that's going to be when negative 16t squared plus 120t is equal to 0. Well, the easiest way to take care of this one is just to factor a negative 16 out. You can factor a negative 16t out, and you're left with t. And then what's 120 divided by 16? I think that goes 7.5. So I tell you what, let's do it this way instead. Let's just factor an 8 out. A negative 8. So if we factor a negative 8 out, you're going to get a 2t here. And then if you take 120 and divide it by 8, you get 15. See that? So you could also use Pythagorean theorem or something like that, but I'm just going to factor it like this. Factor the negative 8t out, you're left with 2t here, and you're left with a negative 15 there. Multiply it through, you're going to get 120t, and you're going to get a negative 16t squared. 0 is your friend. When will this thing be 0? It'll be 0 when t is equal to 0, or when 2t minus 15 is equal to 0, which means 2t is equal to 15, which means t is equal to 15 halves, which is the same as 7.5. Okay? So t is equal to 15 halves, which is same as 7.5 seconds. So those are the two times when this rock, or whatever it is 0, before you ever throw it, and after 7.5 seconds. Okay? There's your answer to number 13. Okay, so now let's go on to number 14. When does the maximum height occur? So I just put it in here. We know that it hits the ground at 15 halves seconds. And we know that for a parabola that it's symmetric about these intercepts here, and so the vertex is going to occur halfway in between. So right there at 15 fourths, which is, how many times does 4 go into 15? It goes in 3 times, and you have 3 left over. 3/4 is 7.5. So 15 fourths, which is 3.75 seconds, that's going to be, this right here is 7.5 seconds. That's when it hits the ground. So right here at 3.75 seconds is when it hits the actual height. Okay, when it gets to the actual height. Or I should say the maximum height. Okay, so there's your maximum height. And finally, what is the maximum height? Well, all we have to do is stick this in, and let's go ahead and see what we get. H of 15 fourths is equal to, if you wanted to, you could stick this into your calculator and get a numerical answer. I like to actually figure it out. So it's going to be negative 16 times 15 fourths quantity squared, agreed, plus 120 times 15 fourths. And this is going to give me 15 squared. I'll go 15 squared divided by, well, let's see, 4 squared is 16. 16 over 16 is 1. So that's just going to be 15 squared with a negative sign out front. That was easy. And then plus, what do I have here? I have 120 divided by 4 is 30. So I have 30 times 15, right? 120 over 4 is 30. 30 times 15. And 30 is just 15 times 2. So this is negative 15 times 15 plus 2 times 15 times 15, because that's what 30 is. And so I can factor the 15 times 15 out. And if I factor that out, I get 15 times 15, which is 15 squared. And I'm left with 2 minus 1 is 1. So that's just 15 squared. 15 squared is 225. So the maximum, if you actually play with the numbers there, 225 feet. So there's the answer to number 15. And we'll continue on from here in the next video.